Today we are going to discuss the covalent and ionic nature of a bond. Okay, now till now we have discussed about the covalent bond and ionic bond, but actually that means practically neither or nor a bond is fully covalent or fully ionic. So in a bond there is some percentage of covalent bond as well as some percentage of ionic bond. Okay, but if bond in which the percentage of the covalent bond is maximum, then the bond is known as covalent bond, and the bond in which the percentage of ionic interaction is higher, then the bond is known as ionic bond. Okay, so how can we explain that which one is ionic or which one is covalent? This can be explained with the help of Fajan's rule. Okay, let's discuss. Fajan's rules explains which bond is covalent or which bond is ionic, or you can say the ionic character or covalent character of a bond. Okay, so let's discuss the points of Fajan's rule. First point is the smaller the size. Okay, size is smaller. Okay, I am writing the arrow in downward direction, that means size is decreasing. Okay, smaller the size of the cation and larger size of anion of an ionic bond. In place of ionic you can write simple bond, ionic bond greater the covalent character. Okay, this one is the main postulates of Fajan's rule. Another postulate is that greater the charge of cation, greater the covalent character. Okay, greater the charge of cation, greater the covalent character. Okay, now let's discuss for what basis this rule is explained. Okay, let's take an example. Suppose it's a cation. It has different orbits in which electrons are moving. Okay, here's the another anion. This anion also have orbit. Now if the size of the cation is smaller, okay, size of the cation is smaller, then the electrons of the cation is closely, that means is strongly attract towards its nucleus. So it has greater tendency to polarize the another anion. That's why. Okay, similarly, if the anion is larger in size, then its electron is easily polarizable. That's why it is known as to form a greater covalent character. Okay, this way. And greater the charge means greater the tendency to attract the electron of a cation. That's why if can attract the greater cation, that means it can polarize the atom. That's why it forms a covalent bond. Okay, this way we have to explain the covalent and ionic character of a bond. Okay, now let us take an example. Example is this way: lithium chloride, sodium chloride, potassium chloride. Now see, anions are same. That means it is positive, negative, no. So anions are same, only difference in their cations. So from lithium to potassium, that means from a period number from a group number 1, that means alkali metal. From lithium to potassium, their size is increasing. That means in converse case of this one, size is increasing, so covalent character will decrease. This as the size is increasing, as the size is decreases, covalent character increases. But here it is from lithium to potassium size is increases, so covalent character will be decrease. So which one will be more covalent? This one will be more covalent than this one. So this should be more covalent, this one is least covalent, this one is medium covalent. So this way we can explain. Okay, so this is the concept of Fajan students. So let's explain another topics. That means up to this much we have discussed the covalent, ionic and coordination bonds. Okay, so let's discuss VSEPR theory. Okay, so let's discuss. Okay, VSEPR theory. Okay, VSEPR. V means valence, S means shell, E means electron, P means paired, and R means repulsion. Okay, so VSEPR means valence shell electron pair repulsion theory. So VSEPR theory just explain how a molecule forms, in what structure, in what geometry the atoms are linked with the central metal atom. Okay, so let's see. Okay, the postulates of VSEPR is this way. Okay, so first postulates is the shape of a molecule depend upon the number of valence shell electron pairs. It may be bonding or non-bonding. Okay, that means what is the number of valence electron in the normal atom of the central metal ion, this will help to form the molecule, and this is taken as the assumptions or taken as a postulates in the VSEPR theory. Okay, second postulate is the pair of electron repels each other. That means electron pairs are repels each other, and as in the molecule two types of electrons may be occupied. First one is the lone pair, second one is the bond pair. Lone pair means non-bonding electron and bond pair means bonding electron. Now the repulsive interactions is this way, that the repulsion between the lone pair electron is maximum, then the lone pair bond pair, and the least repulsion between the bond pair electron. Now why it is least, why it is highest? Least of bond pair repulsions is comes from the stability of a compound, but lone pair interaction, that means non-bonding electrons are not attached with respect to two different atoms, because it is non-bonding, no, that's why these are very unstable, but these are a little bit stable. But repulsion is there, remember this one, repulsion is there. Now pair of electrons, it may be lone pair or it may be bond pair, tends to occupy in a space where a minimum repulsion is there. That means all the electrons tries to attain at a space where the repulsion is minimum. That means if repulsion is minimum, in other sense we can say each pair of electrons tries to attain in a distance from one another. Okay, this maximum distance between them. That's why. So just VSEPR theory explain the structure and the repulsion between the lone pair bond pair, and it's involves with the help of valence shell electrons. Now according to VSEPR theory, the molecules are classified into two categories. First category is the molecule where lone pair is there, another molecule where bond pair is there. Okay, this way it is classified. Now let's see one by one. So first a table of element, a molecule where no lone pair is there, only all the bond pairs. So number of bond pair, if it is 2, then here it is 2. So A is central atom, B are the two atom which is linked with the central atom A. It is in the linear, that means in a straight line. The example of this one is BeCl2 or HgCl2. Okay, if the bond pair is 3, then obviously the molecule should be triangular planar. See, tri means 3, angular means in 3 angle, and planar means in a plane. In a plane. Okay, so and the bond angle between any two of the BB bond, BA bond, then it is 120 degree. Okay, if the bond pair is 4, then it is form a tetrahedral positions. I already shown in a tetrahedral, and the bond angle between the tetrahedral is 109.5 degree. And the examples are this: methane, ammonium ion, carbon tetrachloride. This way. Okay, so let's see some other examples. If the bond pair is 5, then the structure should be trigonal bipyramidal. Okay, now see, trigonal, that means 3 atoms in a plane. See, this 3B atom in a plane, and this B is top of the plane, and this B is the below of the plane. Now why this bipyramidal is given? Bipyramidal means, see, as we know, pyramids look this way, no? Pyramid. And it is 3-dimensional, so this way. Okay, so this way, pyramid. It's cone-like structure. Okay, pyramid, that means this is one corner. That's why it is pyramidal. But here it is, see, one bottom position is also there, in top position, in top position also there, in bottom position also there. So bipyramidal. Bi means two pyramidal. See, trigonal bipyramidal. And the bond angle between this BAB is 90, and this BAB, which is in the plane, is known is 120 degree. And examples is PCl5. Okay, if the bond pair is 6, then the structure is octahedral. So 4 atoms, that means B atom in a plane, and 1 atom is top of the plane, and 2 atom is the 1 atom is the B, which is below to the plane, and each B atom is forms 90 degree angle to each other. And the example is SF6. Okay, up to this much we have discussed today. The next day we will discuss how lone pair and bond pair both are forms a molecule in different orientations. Okay, these are we need to show by simple pen or chalk or pencil, whatever. It will be easy for you. Otherwise in book or paper it will be little bit difficult. Okay, thank you.